All right, honors geometry, you signed up for it. You're going to get it. 6-9 proofs using coordinate geometry. So we're going to do some more work on the coordinate plane, but you're going to see that our pictures are not going to have numbers as the coordinates, but they're going to have like variables like A and B and C. And it's our job to still use the formulas to prove very basic things about geometry. Proofs is almost like a bigger word than we should use. It's almost like verifying things, verifying relationships using coordinate geometry. Okay, and you'll see as we do these. Okay, so again, let me remind you of the formulas. Again, distance formula used to show congruence. Okay, so for congruence, whether it's sides or diagonals. Midpoint formula is used to find the midpoints. We'll use that to show that the diagonals bisect each other. Okay, we'll talk about that. I think I'm actually going to do that one with you. And then slope formula. Slope is always used for parallel and perpendicular, whether it's sides or whether it's diagonals. Okay, so be aware of that. All right, so let's go ahead and fire up our first edge elastic problem. All right, so it says use coordinate geometry to prove that triangle ABC is an isosceles right triangle. So these words isosceles right should mean something to you. So in this picture here, here's your triangle. So I hope that you assume that this is going to be a right angle, and I hope you assume that these two sides need to be the congruent sides in this triangle. So you can attack it either way. Let's go ahead and start with the right portion. So to show that this is a right angle, I must show that segment AB is perpendicular to segment AC. And to do that, I need to use the slopes. All right, so I'm going to go ahead and first talk about the slopes of AB. Now, to get from B to A, right, you have to go down, all right? But we're going to use the actual slope formula, right? So your slope formula is y2 minus y1 over x2 minus x1. So we need to use this. Let's call this x2, y2. Let's call A x1, y1. So to find the slope of AB, so let's use this for AB. I'm going to do y2, which is A minus y1, which is 0, over x2, which is 0, minus x1, which is 0. So A minus 0 is A, 0 minus 0 is 0. Anytime 0 is in the denominator, this is an undefined slope. So what I need you to do is I need you to write down these things. So slope of AB, A over 0, which is undefined. So you'll see that down here. So in here, I'm going to use the math type. So I'm going to find the slope of AB, which came out to be A over 0, and that is undefined. Now, you don't have to use the math type. You can just write things out. I'll show you. So you could just say, you know, M, or slope of AB, equals A divided by 0, which is undefined. I'm okay with that. If you don't want to waste the time of doing that nice, pretty print stuff, it's up to you. Okay. So now let's find the slope of AC. So again, up here, let's label C's coordinates x2, y2. It's farther. Let's label A's x1, y1. So to find the slope of AC, I'm going to take y2, 0 minus y1, 0 over x2a minus x1, 0. That is 0 over a. And now with 0 on the top, the overall answer is 0. 0 divided by any number other than 0 is 0. So again, I need to see slope of AC, 0 over a, 0. Slope of AC equals, 0 divided by a, which is 0. And we need to know that an undefined slope and a horizontal slope of 0 are opposite reciprocals. I did air quotes. They are perpendicular lines. So we now know that segment AB is perpendicular. You can slow my video down to see what buttons I press. Is perpendicular to segment AC. And that means, that angle EAC, or angle A, we'll just call it angle A, is a right angle, which means that triangle ABC is a right triangle. Look at all that fun stuff, right? So that is the first thing I did. I just showed that those two sides are perpendicular. And now we're going to use the distance formula to show the lengths of those two sides. So again, when we do that, you can use, and I think I showed this in the other video, the 6-7, that you can use distance equals rise squared plus run squared inside the square root. And again, if you bring the negative with you, just make sure when you take, like, say it was negative a and square it, when you square a negative, it turns positive. Be aware of that. Now, the one thing you're going to maybe run into is if you have like an a minus c squared, this is a binomial squared, and we'll talk about that when we get there, hopefully today. But again, sometimes you might not have to multiply anything out. All right, so just be aware of that. Okay. All right. So I'm going to use the length of AB. So to find the length of AB, I will need to take the square root equals the square root of. So AB is A squared plus 0 squared. Well, A squared plus 0 squared is just A squared. That's the square root of A squared. And if you take the square root of A squared, that gives you a length of A. The squared and the square root cancel, and there's your length of AB. A. I'm finding lengths now. All right, lengths. Do the same thing with AC. The other side, I think, is congruent. So AC equals the square root of, oh, and again, as I showed, cancel. So you can also just do AB equals, oh, undo that. I want that back, good. AB equals the square root of, and you could just do A squared plus 0 squared, which is the square root of A squared, which is just A. You can just use SQRT for square root if you want to. Again, I think it's a little bit more murky, but that's just my opinion. All right, so AC equals, and again, it's going to be the square root of 0 squared plus A squared. That is also going to be the square root of A squared, which is just going to give you A. And notice now that AB and AC are the same length, so they are congruent. So I know that segment AB is congruent to segment AC, and that means that, not V, it means that triangle ABC is isosceles. Isosceles. Or is an isosceles. Is an isosceles triangle. And there we go. And I've now shown that triangle ABC is a right triangle and it's isosceles. Great. Good for me. Okay, so again, it's kind of weird, but again, don't overthink it. I don't think it's that difficult. It's just weird. Okay. All right, cool. I got 2 more videos coming up. One for each type of formula you're going to use.